So this is Chapter 2, Part 3. We're going to finish up the atom. And we're starting where we left off, which is isotopes. So if you remember that every, say, carbon, there's an atomic number at the top. Okay. So all carbon atoms have 6 protons. That's just by definition. And if it's a neutral atom, if it's an uncharged atom, it will have 6 electrons. But the weight, it's not necessarily true that all carbon atoms are going to have 6 neutrons. So there are isotopes of elements, and those isotopes differ in the number of neutrons. So you might have 6 protons and 7 neutrons. So it's going to have a different weight, but it's still carbon. So all carbon atoms have 6 protons. That's the definition. But not all carbon atoms are going to have the same number of neutrons. So that's what an isotope is. Same element, so in this case carbon, but different number of neutrons. So you look at all the different carbon atoms, they're not all going to weigh the same. Now, most isotopes are stable. But there are some isotopes that we call radioactive isotopes, and they still are isotopes in the same definition, being they differ in the number of neutrons, but they're unstable, and they will emit energy and particles to become more stable. And this was first discovered back in 1896 by a French group, and they noticed that they found rocks that had high levels of uranium and had an unusual property. They were emitting energy, and they were able to prove that by putting the rocks that had uranium into a dark drawer and put them on top of a photographic plate. And just as the energy from the sun will develop the photographic plates, so will the energy that was being emitted from these isotopes. So Madame Curie was working in the lab, and she was the one who actually coined the term radioactivity. So radioactive isotopes, as all isotopes are, they differ in the number of neutrons, but in this case they're unstable and they will emit energy and particles. So we can use that. They'll actually, as they emit particles, they actually become different elements. And we're able to use that to date fossils. We can also use it in medicine. So for instance, a PET scan, you take a patient and you give them a molecule, like maybe a sugar, that has been labeled, has been added a radioactive atom, and that's going to be emitting energy. You can capture that energy. You can give the patient that radioactive labeled compound, say the sugar, and then trace it in the body and see if tissues are taking up more or less of it than they should. So for instance, this is a normal brain, and yes, all of our brains have chambers that are fluid filled, and so that blue area is low activity and higher activity is red. But if you look at this brain, much more of the brain is blue activity, lower activity. That's an Alzheimer's patient. You can also use it to trace tissues that are taking up too much of that molecule. So cancer is rapidly growing, so they take up a lot of sugar. And so that's going to be, you can see a tumor grow. So that's the end of the intro to the atom. The next section, we're going to look at the periodic table, which should be, again, a quick review of the periodic table.